Welcome to Listen Smart Tech. This is our 5th lesson in our data analytics course. Today, we are going to learn how to manage and organize data using multiple tables, and we're also going to learn the importance of splitting data into different tables. When a table has a lot of repeated information, managing it becomes very difficult. So to improve the efficiency of data storage, we can split the data into multiple tables. I have opened a coffee shop as my new side hustle, and I'll have customers with different properties, products with their details, and others with their information. Now, putting all this information in one table will lead to duplicates and inefficiencies in data storage. A more efficient way of doing this is to organize all this data into 3 separate tables. The first table will be the customers table that will be used to store information about the customers. We will have 4 columns in this table: the customer ID to uniquely identify each customer, the names of customers, their emails, and their phone numbers. The second table will be the products table. This will be used to store details about our products in our store. With 5 columns, we'll be able to identify each product with the product ID. We'll have a name column, price description, and category. The third will be the orders table to record customer orders. The first column will be the order ID to uniquely identify each order, the customer ID to know the customers which ordered, the product ID to know the products ordered, the order date, and the total amount. To understand how this works, let's take a look at the orders table. We see that the first order was made by a customer with ID of 1, and that is Alice Smith. To find the exact item she ordered, we can refer to the products table, and we see that product ID of 1 is the espresso coffee. Imagine you would want to view each customer and the order they made. You can use an SQL query to join the customers table and the orders table. In this query, select star retrieves all rows. From orders, specifies the first table we want to select. Join customers indicates that we would like to join the orders table with the customers table. The last sentence with the on clause matches customer IDs in the orders table to customer IDs in the customers table. Let's take a look at the join table. The first 4 columns are coming from the orders table, and the next 4 columns are coming from the customers table. Customer ID doesn't appear twice because the 2 tables are joined on the customer ID column. The inner join retrieves only rows that have matching values in both tables. For example, if a customer with an ID of 5 made an order that was recorded in the orders table, but this customer was not recorded in the customers table, this will be excluded in the results set. This query is used to make an inner join of the milky orders table and the dark orders table on the customer ID column. And this is the result set of the inner join. The left join retrieves all rows from the left table and all matched rows from the right table. So all unmatched rows in the right table will return null. In this example, we have 2 tables, table 1 and table 2, and we are making a left join of table 1 with table 2 on the fruits column. This is the result of the left join, and we see that the rows in table 2 that do not have matching values with table 1 record null for those particular columns. On the other hand, if we want to find the fruits that appear only in the first table, we can use the where clause to retrieve all rows that have null values for the fruits column in table 2. Primary keys and foreign keys. The primary key uniquely identifies a row in a table. For example, we could have IDs to uniquely identify each row. And a foreign key in one particular table is a value that serves as a primary key in another table. For example, right here we see in the authors table, the author ID is the primary key. But in the books table, author ID is the foreign key because it's the primary key for the authors table. Here's an SQL query to perform an inner join of two tables using primary keys and foreign keys. And this is the result set of the inner join. The cross join matches every row in one table with every row in another table, hence generating a Cartesian product. Right here, we have the animals table and the habitats table. We would match lion with savannah and jungle, and we will match elephants with savannah and jungle. Here is the SQL query to perform this operation. We would select the rows we would want to perform the cross join on. That is the animal name in the animals table and the habitat name column from the habitats table. So from the animals table, we'll cross join to the habitats table. So we see in our results set that we have 4 rows, and in each of the columns we selected, we had 2 rows each. So in the results set, the number of rows is a product of the 2 columns in terms of the number of rows they both have. The union. This combines 2 data sets by stacking one on top of the other. So for example, we could have March orders and April orders. And we want a table that contains these 2 data sets. So we could use the union in a query like this. So we select the ID and order date columns from the March orders table, and we unite it with the ID and order date columns in the April orders table. Here is the result of our union. The with clause, also known as common table expressions, helps us to create temporary result sets or tables that can be referenced in an SQL query and operated upon. So let's take this example. Right here we have the March orders table and the April orders table. What we want to do is that we want to sum the total sales in March and sum the total sales in April. With the with clause, we will create temporal columns to hold this summed data, and we can reference it in our SQL query. Let's take a look at this. So the first thing we'll do is we use with to create a temporal table called March sales, and then we select and sum the total amount from the March orders table, and we rename it to total March. Also, in the April orders table, we create a temporal table called April sales, and we sum the total amount column from the April orders table, and we rename it to total April. So now in our query, we will select the temporal columns total March and total April from the temporal tables March sales and April sales, and we'll display it in our results set. Here we have it. Here are some review questions for us to try our hands on. We have the answers after each question. If you found this tutorial helpful, you can leave a like. In case of further questions, you can drop a comment in the comment section. If you want to see more tutorials like this in the future, please subscribe. Until next time, bye bye.